Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
In this video tutorial, we will continue working on our TerraClimate database or data product, and specifically with the coefficients that we generated from our multiple regression equation or multiple regression function. Remember, in our video tutorial 62, this one here, we generated a constant maximum temperature coefficient and a wind speed coefficient for our dependent variable, which in our case is PR, which stands for participation or rainfall. So we generated this multiple regression equation within Earth Engine, and then we generated an image for that specific function for our region of interest as a whole, and which is these three. By the way, we generated a normal OLS, a normal linear regression function or equation, but we also generated a robust linear regression, which is basically just the coefficients are in most cases, the T that you get from the robust is a better indication of the true value or the statistical significance than the normal OLS. So it's not that the coefficients will be significantly different. It is just the significance of these coefficients. So with robust, these coefficients are more likely to be statistically significant than these ones. Anyway, you can read up on that. Okay, so we generated an OLS or a multiple regression equation for our dependent variable, rainfall, based on a constant maximum temperatures and wind speed. We're displaying it in our image as a layer. Okay, and we generated the coefficients for my region of interest as a whole, meaning this is for the whole area. But we also, using the inspector, we can generate coefficients for each individual location. Well, the location that you actually choose. But what I want to do now is, and I have to be honest here, I'm still struggling to determine how to do this in Earth Engine, and that is to generate, well, is to allocate these coefficients, let's say these coefficients, if we have individual points here, random points or structured points here, 200 or 50 or whatever the number of points here is per pixel. Okay, so it's no point having 2 points per pixel because they're going to have the same coefficient. So you actually want to generate a point, a location, a centroid for each pixel, and then calculate or generate the 3 coefficients for each pixel. Okay, so I'm still trying to figure this one out in Earth Engine, but in the meantime, what I thought I'll do is just do that in QGIS and to show you just what I'm trying to do. Okay, because remember, most, if not everything that we're doing in QGIS, in Earth Engine, we can do in QGIS. Okay, except obviously generate the images itself, the primary images and primary data. That's always a function of Earth Engine. Okay, so what we need to do first of all, once we've generated our image and our coefficients, and then we need to export these images. Okay, so what I'm going to do is I'm going to export my linear regression image, this one here. I'm exporting my robust linear regression image, which is this one here. Okay, so that's my linear regression, and that's my robust linear regression. And I'm also exporting my rainfall image. Now, our rainfall or participation image is the one that we generated here on top, which is basically a median image. There we go, this one here. It's a median image of this variable for this period of time clipped to my region of interest. So they're all basically a median functions of over this period of time or within this image collection. Okay, so remember I'm using this script to export those images. So I've got 3 images to export. I run it, and then those tasks would come and sit within my task manager. Okay, There's a PR and there's the 2 images. Now, basically, I've already downloaded those images. Basically, just press run, and they will upload or download to your folder. Remember here, I've specified my folder is called project within my Google Drive. It's already, if it's blue, it means you successfully have downloaded. So if I go to my project folder in my Google Drive, you'll see there's the participation and there's those 2 images. The linear regression image and a robust linear regression image. Okay, so basically you just click on this little buttons and you download it. Okay, so I've downloaded all 3 of them. They're now in my project folder on my desktop or in my laptop. Okay, so that's how I get the images out. Then once I've done this, I now open my QGIS. Okay, I open my QGIS, I go project, I go new project. I've already done that. Okay, and then basically I upload those images. There's the images. Okay, so let me just show you. Okay, so you go to layer, you go to add layer, you go to raster layer, and within this function here, you go and search for your images. And you'll see there sits my 2 images, my normal linear regression image and my rainfall or my participation image or raster, and my robust linear image or raster. So you just click on it, you just say open. You can click all of them together and open, etc. They will sit here. Okay, so let's have a look and see. So once I've created my project now, it's a new project and I've saved it. Okay, so I've saved it as a clear time. So I say open as a new one. Once I knew it's save as. Okay, then I add my layers using my add layer function. It's raster layers that I'm adding, and those are the ones that I've generated in Earth Engine. Those are the 3 that I've generated in Earth Engine. Okay, that to PR, linear regression and robust linear regression. There's the 3 of them. Okay, which are now in my folder, my Google Drive folder. There they sit. Okay, so that should be straightforward. Okay, so there it is. So there's my linear regression function. Okay, there it sits. It looks like that, and it's got 3 bands. Band 1 is a constant. Band 2 is the maximum temperature. Remember, these are the coefficients. Ne? So that's the constant. That's the maximum temperature coefficient. And that's the wind speed coefficient for each of these pixels. You see, you can clearly see the pixels now. There they sit. And they basically the spatial resolution as indicated in the Terra Climate. So if we go to our Earth Engine and we go to data sets and we search for Terra Climate. Remember, in the landing page of each of these data sets of products, they give you the spatial resolution. There they sit. Okay, so 4,638 meters. So it means that the spatial resolution, these squares, are 4,638 by 4,638 roughly. So each of these squares are 436. 4 kilometers squared. Yeah, 4.6 kilometers squared. Okay, so that's the size of each of these pixels, and that is determined by the spatial resolution of the data set itself. Okay, so let's have a look and see what's going on here. As I said, the band, the red, is the constant. The band 2 is the coefficient of maximum temperatures, and band 3 is the wind speed. Now, each of these ones will have a different set of coefficients. So if I go to this indicator here, then I can identify features. So let's say I press on that button here, and then the coefficient should display here. So for that specific area there, that green area, its coefficient is 117. Its maximum temperature coefficient, its constant, sorry, is 117. Its maximum temperature coefficient is minus 0.38, and its wind speed coefficient is 0.01. Okay, remember maximum temperatures are in Celsius, wind speed are meter per second. Okay, constant would be in millimeters because we are modeling rainfall. Rainfall is millimeters. If I go to this green, well, let's take a red. Okay, so red is a constant of 133, maximum temperature or coefficient of minus 0.4 and a wind speed of 0.01. So you can see each of these locations or each of these pixels within my region of interest have a different set of coefficients. And that is exactly the same as when we in our Earth engine use our inspector. Okay, so if I were to get basically the same location, and that's going to be quite difficult, but let's see if we can do it. Let's go and see if I can do, okay, let's see if we can do this location here, that little one there. Okay, so let's see if we can do the same one in Earth engine. Yeah, it's going to be difficult. Okay, so let's see if I've got it roughly wrong. Or right, sorry. Yeah, you see there, 151. Constant is 151. Constant is 15146. Let's see if I've got it. 146, yeah. Temperatures is minus 0.5, minus 0.5. You can see it's exactly the same. Voila. Okay, so, and then there is my robust one, exactly the same. I can also again, so if I select both, I can then click on a location, let's say this blue one here, and I can get the coefficients for both those locations. For the same both set of coefficients for that location. The coefficients for the normal linear regression, and then also the coefficients for the robust linear regression. If I just select both of them, and then I can select any location, and you'll see it is open there. We just need to open it there, and there it sits. Okay, so that's essentially the same as what we've done here, nothing different. But what I want to do now is I want to generate a centroid for each of these pixels, meaning I want to generate a point layer for each of these pixels, a centroid if you want to, and then for each of these pixels allocate its coefficients. So if there's 200 or 300 pixels, each pixel points. So if there's 300 pixels, then it will be 300 points. And each point will have a constant maximum temperature coefficient and a wind speed coefficient. Okay, and the reason why I want to do that, and I'll show you why I want to do that. Okay. Okay, so that is essentially what I want to do. And this is what I'm still struggling in Google Earth. So any of you have ideas on how to do this in Google Earth, please let me know. Because at the moment, Google Earth or the tutorials indicate that I have to work with the image collection. And this is not an image collection, this is an image. Okay, so anyway, so we can generate the points in Earth Engine. That's not a problem. It is to get those as coefficients for each of those points. Anyway, so first thing that I want to do is I want to remember at this stage, these images, if I right click, I go to properties, then these images are in degree format. Okay, they are in degrees. They are in degrees because they are, yeah, you can't see it here, but they are in degrees because it is got this reference system. Okay, so that's first of all what I have to change. They are in a degree referencing system, so I need to change it to a meters referencing system. Okay, so that's the first thing that I want to do so I basically just go to rasters and I go to projections, I go to wrap, I get my image, I select the current source, which is, or the referencing system, which is degrees, and then I'm using the pseudo Mercator, presume that's how you pronounce it, referencing system, and that is in meters. So all I'm doing is I'm changing my images from degrees to meters, and I press run, and there they sit. Okay, so I've taken both of these two images, which is the images as downloaded from Earth Engine, and the first thing I do is I convert them into images that's within meters. And I just make them same name just with RE, meaning reproject. So if I right click on it now, you'll see it's got the same colors, same everything, nothing changes except you'll see that if I go It says meters. That's what I'm looking for. It says meters. Okay, so I don't want degrees. I don't want to work with degrees. I want to work with meters. Okay, I don't want to work with degrees. You see, there's degrees, units. I want to work with meters, specifically when you want to generate sizes. Okay, and that's quite important as well. But as I said, why I'm converting it, I want to work in meters. So that's my first thing. Okay, so in fact, you can now discard these two because you're not going to work with them again. So I'm just going to remove them. So there they sit. It's exactly the same. If I highlight both of them, if I press the display, I go back to this one here, you'll see they give you the same numbers. So the coefficients don't change, the color schemes don't change, nothing changes except you go from degrees to meters. And that's important, as I said, when you start working with sizes, distances, and all these things. Okay, and then also these are, okay, so these two are my functions, my coefficients, constant coefficient, maximum temperature, and wind speed coefficients. Those are indicated in these two images, which is my normal linear regression, my robots. But I also downloaded my dependent variable. Okay, and I've downloaded the dependent variable, and I also converted it into in meters, into that. If I go there, into that source, into that pseudo Mercator coordinate reference system. So that's also now in meters. So all three of them now are in the same coordinate reference system, and they are in meters. So that's always important. So I can delete that one again. So the ones that I've downloaded from the ones, okay, let me save, always save. So the ones that I've downloaded from Google Earth were in degrees. So I uploaded into QGIS, and then I converted into meters, and then I delete or remove the original ones because I'm not working in degrees, I'm going to work in meters. So there is my three. So basically you can say, there's my dependent variable, and there's my independent variables. There's my dependent variable, and there's my functions. Okay. So okay. So now what we want to do is we want to generate a centroid for each of these pixels. Okay. We want to generate a centroid for each of these pixels. So how do I do that? First of all, I remember the pixels are exactly the same size. Okay. So if I go in, you'll see the three of them have exactly the same pixel size. Okay, so I can use any of the three of them. Okay, I can use any three of them. Sorry, just go back to hand. I can use any three. So what I do is I convert any of them using those conversion from a raster to a vector. So any one of them. Let's use this one, for example. And I just press run, and it's going to convert it. Okay, so there is the, okay, now maybe not that one because, okay, so let's not do that one because you can see it's got some pixels that have been merged in the conversion process, and I don't want that. So remove layer. So let's go with this one here. And so we're going to use that one. We're going to go to raster. We're going to go to conversion, and I'm just going to run it. And you see there's the conversion. You can see all the pixels. So there's an outlier. I want to get rid of the outlier. So I go to the vector. I go to open attributes. I activate the open attributes. I press on DN to make it in, to basically sort it. So there's all my zeros. So I basically just highlight all my zeros, meaning I control and left click, and then I just delete them either by a cut or by the delete. Sorry, let me go back to it. Open attribute table, that scissors, and once I delete it, I just untoggled my editing mode, and it will save, and voila, there it sits. Okay, so there's all the, and if I where's my symbology? If I change the transparency, okay, so you'll see that the pixels are basically, okay, let's change there. you can see the pixels are very much similar. You can see the pixels are similar. There's some pixels that have merged, but that's not an issue because if they have merged, it means that their coefficients should be exactly the same. But you can see the vectorized image, the pixel boundaries and sizes are same as the rasters. So what I do then, I go from the vector, and now I can go to vector, and I can go to my geometry tools around the centroids. Okay, so I go to vector, I go to centroids, and I run it. And you see there they sit. Now I've got a centroid or a point layer for each of those. You can see there, so for each of those raster cells or pixels, they have a point. There's some where it's merged. You see there's nothing. Okay, so it's not 100%, but it's 99% okay. Okay, so I've done that before, so let me delete these two layers. So let me remove them. And there I'm sitting with it. There I'm sitting. If I go into its attribute table, you'll see there is the unique value. There is the X and Y coordinates of each of those. And there is 204 of them. So there's 204 pixels or points, 204 of them. So what we want to do now is obviously we want to generate the coefficients that's in these images to the raster points. Okay. So how do we do that? We go to our toolbox here, our processing toolbox. Remember, there's our toolbox. You go to processing toolbox, and it will come up here. Okay, so processing toolbox, and we look for something that's called sample raster values. Okay, this one here, sample raster values. Let me put it there, raster values within our toolbox. Okay, so I'm going for this function here. So here I'm going my input layer, which will be my raster, my points. Okay, then I'm select my image, and first of all I'm going to do my normal linear regression. I'm not going to worry about a prefix now. I'll show you why I'm not worried about. Let's call it X first of all, and let's call it A. Okay, and I press run. Okay, let's see what has happened. Okay, so if I go to sampled, that's a new one. I go to open attribute table. You'll see, voila, there it sits. There's my coefficient. There's my temperature. There's my wind speed. So now for each of these points, I've now generated these three coefficients. And let me do it for, so now let's use the sample one and use the robust one, and I'm going to call it B. And let's run it again. Okay, so now I'm going to close it. Now I've got two samples. If I open this one that I've just created now, if I go to open attribute table, you'll see there is the linear regression of the normal linear regression coefficients, and there is the robust linear regression coefficients, each for each location. Okay, so there's the constant, linear regression constant, maximum temperature, linear regression coefficient. Sorry, let me start again. There is the constant coefficient, constant, linear regression constant, maximum temperature coefficient, wind speed coefficient, for the linear regression for that location. There's the constant, the maximum temperature, the wind speed coefficients for the robust linear regression for that location eventually. Okay, so there they're sitting all. Okay, but now I want to change these names. Okay, A1, A2, A3, B1, B2, B3. I want to give them proper names. Remember, if you finish with something, remove it. So I'm going to go to, remember that, so that's sample raster values. So I'm going to go to a rename field function. So I'm going to choose my sampled, and now I'm going to change my name. So A1 becomes coefficient linear regress. Now, it can't be that long. So I'm going to say linear regression coefficient. Okay. Okay, so we have to do it one by one by one. So that's just going to take too long. We can do it as in batch, but okay. I wanted to change the names, but it's going to be, you can't do it all in one. So I can do it as a batch, but I'm not going to do that now. Just leave it. As long as we know that in this point, A1 is the linear regression constant, A2 is the maximum temperature coefficient, and A3 is the wind speed coefficients for the linear regression, and these are the coefficients for the robust regression. Okay, so what I want to do now is that what I want to get to, let's keep this open, is to say, okay, if I go to properties, okay, and if I go to graduated, okay, now I can do heat maps, I can do all sorts of things, but if I go to graduated, and let's say coefficient, and I go to, let's say the constants, okay, so A1 is the constant. I go to my turbo, I go to equal interval, I go classify, go apply, and go. Let's take these ones away. Okay, so now what it says. Okay, sorry. Okay, so you can see the blue. As blue locations have coefficients of 103 to 115. Okay. The dark red is located all here. So you can see a clustering of the coefficients. You can see all the green coefficients, which is 115 to 128, is clustered around this area. The blue coefficients, the coefficients 103 to 105, 115 is clustered around this location. The high coefficients, 140 to 152, is around this. The low coefficients, this 91, is clustered around this. You can also see the majority of coefficients is between 115 and 128. Now, if I go to my, you can see the majority of the coefficients we said is here. The coefficient is 133. If I go to my QGIS, let's have a look and see. 133 is lying in this red part here, which is, that's a problem with working with the mean. Anyway, so that's interesting. Now, what we can do is to get understanding, we can overlay it with our rainfall. So you can see here the dark red ones, the dark red constants are located where there's high rainfall, but so are the low constants. So it's a little bit all over the place. But it gives you an indication of the location characteristics or the regression characteristics per location. And I can do the same, let's say, let's go for the, this is maximum temperatures. And I go classify, I start with equal interval. I go apply and I go, okay, so let's have a look here. So the high maximum temperature inverse negative or inverse maximum temperatures are those black ones. They're located here. You can see there. The small coefficients, negative coefficients, the brown ones, they are located there. And you can see the green ones, they are located here, and the blue ones. But again, you can see the clustering effect. Now that makes sort of sense because, it rains. It rains in similar patterns in similar areas. So in a wide area, it will rain a similar amount versus a next large area. So that's the nature of temp. I mean, it's hot in a specific region. It's not hot in one small location. It is high temperatures in a quite big area. So therefore, it makes sense that these things are going to be clustered. And that's why I want to calculate these things, because now we can generate heat maps, for example. So if we do this now, we can generate potentially a heat map of, let's say, which one shall we choose? Let's say our maximum temperature coefficient. I'm going to go with turbo again. Let's say apply. Okay, it doesn't really show anything because it's so scattered. And there's not a lot of them. So that's not really going to be of any good. However, as I said, let's go and look at wind speed and see what is wind speed. What's the patterns there? Equal interval, classify. Let's press it there. And again, this looks a bit more random. Yeah, except you can see clearly the mountainous area here. You can see, yeah, this looks a little bit more random in terms of wind speed. You can see there's the red areas, is high wind, the black areas are high wind speed. This is around the mountainous areas, high wind speeds. And you can see it's also quite rainy, because remember, the darker the color, the more rain it is. If I look at rain, you can see dark colors is high rainfall, light blue, white is light rainfall. You can see where there's dark colors, it's high rainfall, but you can see it also coincide with high wind speed coefficients. So there's some element of significance here that we can term. Anyway, that is what I wanted to just to quickly show you guys, is the interaction between Earth Engine and QGIS. QGIS obviously is easy to work with. If you know the functions, then it's easy to work with, and you can just generate these things as well. You don't have to do everything in Earth Engine, but remember, as I always say, Earth Engine is the beginning of the whole journey. Everything starts in Earth Engine. The primary data images are all in Earth Engine. Then it's up to you to decide whether you want to continue working in Earth Engine, or to what stage you want to work with Engine, and what you want to do in QGIS, and to what you want to do in QGIS. There's some stuff you can't do in QGIS that you can do in Earth Engine, but in most cases, 99% of the things you want to do in Earth Engine, you can also do in QGIS. So that was just a video to show you the power of combining Earth Engine and QGIS, and what you can do in QGIS with when you generated the data and the images. And this is something that we're going to do quite a bit. Once we've exhausted the work in Earth Engine, we're going to shift our attention to QGIS and basically, continue with our work, because I think the real value, the real application of what we're doing in remote sensing comes alight in QGIS or in your GIS platform. Okay, so yeah, thanks for joining me. Thanks for staying the course. Thanks for accompanying me on this remote sensing journey. I appreciate your presence. Please feel free to send me your comments and suggestions. And please remember to like, to share, subscribe. Sharing is caring. And yeah, stay tuned. I will see you on the other side.